Bismillahirrahmanirrahim. Welcome to Cambridge Maths. Today we are going to solve two questions from mechanics, and the questions belong to paper 9709/42 for the session May June 24. Let's read question number 3, which says four coplanar forces of magnitude P Newton, 10 Newton, 16 Newton, and 2 Newton act at a point in the directions shown in the diagram. It is given that the forces are in equilibrium. Find the values of theta and P. So, this is one of the most interesting and simplest questions. So first of all, what we will do, let me complete drawing the diagram. If we draw some triangles, then it will be easier for us. Okay, this is the first triangle and it will be the second triangle. Second one is here, then the third one is this one. Okay, well, so first of all, we should know that the forces are in equilibrium. That means there is no resultant force either horizontally or vertically. So let us start our solution. What we will do, first of all, we resolve the forces acting horizontally. So for horizontal forces, let us calculate horizontal forces, horizontal component of forces. Okay, first, always the force acting along the positive axis of x causes the positive force. So, positive direction. So, for positive side from the point of direction is 10. First force from the first triangle, it is 10 cos 25. For horizontal axis, our formula is cos the angle of cosine angle. So cos 25 degree. Then rest of the triangles are lying on the left side of the origin. That means they are in negative direction of x along x-axis. So they will be subtracted. Minus 2 Newton second triangle, 2 cos 40 degree, 2 cos 40 degree. Then minus the third one is this triangle. Look at this, it is 16, but we cannot use cosine degree here, cosine angle, because look at this. If we look at the triangle, actually we are resolving the forces horizontally. That means this axis is in term of this triangle. This is not a horizontal axis, this is in term of this triangle, this is a vertical axis, perpendicular line. So it is going to be sine instead of cos. Sine theta equal to, as the look at this, in the question it is written the forces are in equilibrium, so there will be no resultant force. That means it is 0. After that, let us simplify this. So 10 cos 25, we are supposed to find the value of theta. Okay, so sine theta, 16 sine theta, 16 sine theta equal to 2 cos 40, 2 cos 40, sorry, not 2 cos 40, it is going to be 10 cos 25, 10 cos 25 degree minus 2 cos 40 degree, 2 cos 40 degree, or sine theta is equal to, or theta is equal to, simply we can write theta is equal to sine inverse of, if we transpose sine to the other side, sine inverse of 10 cos 25, 10 cos 25 degree minus 2 cos 40 degree over 16 from the left side. So this is the value of theta. Hence our theta is going to be, let me calculate using my calculator. Sine inverse of sine inverse of 10 cos 25 minus 2 cos 40 degree over 16 equal to 28.07. So if we round it up to three significant figures, it is going to be 28.1 degree. So this is the value of theta. One of the values have already been obtained. Now the remaining value is P. So for P, we can resolve the forces vertically. Let us see the diagram. Before that, it is going to be, now we are going to resolve the forces vertically. Okay. If we resolve the forces vertically, let us see which forces are acting vertically upward. So there is no other force acting vertically upward except this P. So P Newton is the upward force. P minus rest of the forces are acting downward. So we will subtract the from the first triangle, as it was for finding x-axis or horizontal component, we use cos formula. Look at this here, cosine formula. So for vertical axis, I mean for this one, we will just use sine angle. So it is going to be, okay, P minus, this one is 25, 25, sorry, not 25, sine, sorry, 10, it is 10, 10 sine 25, sine 25 minus another triangle, that is 2 sine 40 degree, 2 sine 40 degree. The third one is, here in the third one there may arise a question that we are not going to apply sine formula, because what we need, we are actually working on, we are finding the component of this one. Okay, this this axis or this side, this is in term of this triangle, this is not vertical line, this is horizontal line. So it is going to be, instead of sine, it is going to be 10 cos, 10 cos 40 degree, sorry, theta, 10 cos theta. Now if we simplify, our P is going to be, P is equal to 10 sine 25, 10 sine 25 degree minus 2 sine, not minus, it is going to be positive, because the expression, the quantities are changing their position from one side to the other. So 2 sine 40 degree, 2 sine 40 degree plus 10 cos theta, 10 cos theta. So cos theta is actually 28.1, or you can write 0.7 degree, 0.7 degree. Hence our sorry, our P is going to be, P is equal to, if we calculate using our calculator, let's do so, 10 sine 25 plus 2 sine 40 plus 16 cos 28.07 equal to 19.63. That means it is going to be 19.6. Hence, so this is the last of all steps, that's why we can write hence symbol over here. Hence our P is 19.6 Newton. So our answer, this is one of the answer, and already we have obtained another answer over here. That means the value of angular theta. So this is what the whole solution is. I think you faced no difficulty to understand this, because this is one of the easiest and simplest questions. Let's move on to the immediate next question. Question number 4. Question number 4 says a car has mass 1400 kg. When the speed of the car is v meter per second, the magnitude of the resistance to motion is k v square Newton, where k is a constant. Question number A says The car moves at a constant speed of 24 meter per second up a hill inclined at an angle of alpha to the horizontal, where sine alpha is equal to 0.12. At this speed, the magnitude of the resistance to motion is 480 Newton. First question says find the value of k. So value of k can be extracted from here. We can extract k from here. It is kv square, that is resistance to motion. At the same time, they have given one digital value, exact value. This is 480 Newton. So simplifying this, I mean forming an equation, we can do this. They have told that k v square, and what is the value of v for velocity? Velocity was 24. So they have given k v squared is equal to 480. Kv square is the resistance to motion. 480 is also resistance to motion. So k is equal to 48, sorry, 480. 480 over v square. V, how much is our v? V is 24 meter per second. So 24 square. If we divide 480 by 24 square, this is not actually 242. It is 4 square. Okay. Hence, our k is going to be 480 divided by 24 square means 0.833. 0.833. That's all about the solution to question number, first part of question number A. Let's see what the next question says. Find the power of the car's engine. So when the car was sliding up or moving up a hill, we should show the scenario. Let me draw a graph like this. The diagram will look like this. So this is the plane inclined at an angle alpha, and this is normal reaction. What is this? This is weight, and our angle is what? Alpha. Let me draw it again. Let me erase this first of all. Yes, this is the inclined plane, and angle of, yes, this is normal reaction, and this is weight causing it moving downward. That means causing resistance. So this is our triangle, and here the angle of elevation is alpha. Well, this is the car which is moving up the hill. Well, this is the system actually. So let us solve the equation. First of all, they have told us to find the power of the car's engine. So for finding power, we can apply the concept of the motion law of Newton. So if we solve the forces, resolve the forces horizontally, what is it going to be? That is, the car is moving upward like this. Okay, so driving force, the concept we are going to apply is driving force minus resistance force is equal to mass into acceleration. Let's see what is the driving force. Driving force is nothing but power over velocity. Power over velocity minus resistance to motion. Look at this, resistance to motion, that is, that means the plane is not smooth, it is surface, and there is a resistance to motion which is 480 Newton. So minus 480, minus 480. At the same time, we should not ignore the weight. Weight is also causing resistance to motion. So what was the weight? The mass of the weight is actually what? Mg sine alpha, because this is actually the parallel to the horizontal axis, means its movement. This is our horizontal axis. So in term of the triangle, this is no more horizontal, this is our vertical line in term of the triangle. Remember, so don't get confused. For horizontal component, we always use cos theta, but as this is not horizontal, lying on the horizontal, this is just inclined plane. On the inclined plane, so in case of inclined plane or hill, it is just parallel to the vertical component of the triangle. That's why this is mg sine angle. Well, then the right side is mass is 1400 and acceleration is 0, because look at this, the car was moving at a constant speed. The car was moving at a constant speed of 24 meter per second. As there is the constant speed, so there is no acceleration at all. So right side is going to be nothing but 0. Well, power is to be obtained, so P over V minus 480, we can write them on the right side. And velocity, okay, velocity can be written, velocity is given, constant velocity was 24, just we have seen, it was 24, equal to 480 minus mass of the car is 1400. This is the mass of the car, 1400, 1400, and acceleration due to gravity is 10. So if we multiply 1400 by 10, it is 14,000. Then sine alpha. Sine alpha is also given. How much is the value of sine alpha is 0.12. So into 0.12 into 0.12. Then we require actually P. So for finding P, what can we do? We will just do cross multiplication. So our P is going to be, if we multiply this, P is going to be, if we multiply 24 into 480 minus, will it be minus? Not at all, because they have changed their position from one side to the other. So plus 14,000 into 0.12 into 24. Then calculating our quantities, hence our P is going to be, let me write just over here, yes, then our P is going to be equal to, let me use my calculator, so 24 into 480 plus 24 into 14,000 into 0.12 equal to 51,000, 840 watt, 840 watt is our power. Okay, this is what the answer is. We may leave this as watt unit, because SI unit of power is watt. So this is how we can solve the question number, second part of the question number A. That means we have found, what did we get? We have found the power acting, power of the engine acting when it is moving up the hill inclined at um, alpha. Okay, so then let's see the next question, question number B. What does B say? B says the car now moves at a constant speed on a straight level road. Given that the engine is working at 554 kilowatt, find the speed. Okay, so they have told us to find the speed. Now we are going to apply the same concept actually. That means the concept of the motion law of Newton. Well, so for motion law of Newton, now it is just, the difference is, in question number A, it was moving up a hill inclined at alpha degree, but now it is moving at a straight angle. I mean, at a plane, it is written straight level road. This is straight level road means, suppose this is the road, it is moving onwards. Well, so the concept will remain same. What is our concept? If it keeps on moving onward, it is just horizontal level road. So driving force, the concept of motion of Newton, driving force minus resistance force is equal to mass into acceleration. And they have already disclosed that the speed of the car is constant, means there is no acceleration at all. So driving force is nothing but P over V as we have applied in the previous case, and resistance force, resistance to motion is what? It is no more 420 480. Don't get confused. Look at this. Here they have given 480 was for the question number. This is 480. Okay, this 480 was applicable for question number A. So we cannot use this data for solving question number B. It's a different scenario. So what was the resistance motion? Common resistance to motion was kv square. So we'll use k, and the value of k is 0.833. 0.833. So this is our resistance to motion minus 0.83 0.833 v squared. Okay, minus the another force which is caused due to weight. We have calculated here. Look at this. What was the resultant of weight? This was our resultant force of weight, mg sin alpha. As it was sin alpha, angle was here alpha. Okay, now as the car was moving a straight level road, so angle is no more alpha, it is just 0. Here it is going to be 0. Okay, so instead of sin alpha we will write sin 0, because initially in the previous case the car was moving at an inclined angle of alpha. Now car is moving on a straight level road, so straight level road. Okay, straight level road is this one. So here it is no more alpha, it is actually 0. Okay, here it is 0 degree. So we will write mg 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 sine 0 degree equal to, there is no acceleration at all. Look at this, speed is constant, so it will be 0. Acceleration is going to be 0. Then P is to be used 54 kilowatts, so 54,000. Power is given 54,000, and velocity is to be obtained minus, it is going to be, if we transpose this to the other side, I think it is not necessary. What is it going to be? 0.833 v square, and sine 0 is 0, so mg sine theta is also 0, equal to 0. Then if we keep on writing more, it is going to be, let us simplify this. It is v, so 54,000 minus 0.833, v into v is v cube, equal to 0. Hence we can find our v is equal to, if we isolate v and make v as subject, it is going to be 54,000 minus 0.833. It is no more v square, it is going to be v cube. v cube v cube is equal to 0. Well, if we isolate v, then what is it going to be? Our v cube is going to be, or v, simply we can write v is going to be 54,000 over 0.833, and it will be, if cube is transposed to the other side, it is going to be cubic root over raised to 1 over 3. So this is not the last step, hence our velocity is going to be, let us divide this 54,000 over 0.833 raised to 1 over 3 it is v equal to 40.16. So we can, if we round it up to three significant figures, it is going to be 40.2 meter per second, which is the constant speed we should obtain. So that is what the answer. So what have we learned from this solution? This is not exceptional to the previous one. We have applied the same concept to find the required quantities, but the difference between question number second part of A and B is in B the car was moving in a horizontal straight level road where the angle is 0 degree, and in previous case the angle was alpha. That is the difference. Otherwise the whole concept was identical to each other. I think you have understood it well. So thank you for watching the whole of the video, and I may show you number 4. This is sorry, number 3. And fi amanillah. Here it will be an answer. It was the final answer. Okay, fi amanillah.